As software pervades our lives, software failures have become increasingly expensive. This video demos a tool to more effectively find bugs and reduce the cost of software failures. The basis of our tool is symbol execution, a well-known technique for systematic checking of program behaviors. Traditional symbol execution is expensive, and scaling it remains a hard problem. Our tool is based on a novel insight into scaling symbol execution, which is to record and reuse the results of symbol execution across different runs of the technique. Our tool memoise enables the reuse for three common scenarios of applying symbol execution, namely iterative deepening, regression checking, and heuristic search. This video demos the first two scenarios. Specifically, memoise builds a try to record past exploration information during a run of symbol execution, and for the next round of symbol execution, the try is reused to guide symbol execution to explore only paths of interest, and the try is also updated according to the new path exploration and is stored for future reuse. The memoise website has detailed information about how to download, build, and run memoise. So here's the Eclipse, and to run memoise, we also need Java Pathfinder and Symbolic Pathfinder. In this demo, we use a small example program, EX, to illustrate how to use memoise. First, we need to build a try for use, and here's GPF configuration file for that. We use try build to build a try on the fly. Now we run it. After running this, we should get a try file, and we can print it to a dot graph for visualization using the util class provided. After running that, we should get a dot graph, so we can see several nodes are highlighted. The gray node is an unsatisfiable node due to the unsatisfiable path condition, and the two pink nodes are boundary nodes because of the chosen depth bound. Next, we show how to use memoise for iterative deepening. Here's a configuration file for that. We increase depth bound from 6 to 7 to check more behaviors, and we use ID listener for iterative deepening. We run this, and after running it, we should get a try file, and also similarly we can get the dot graph. So we can see that only nodes highlighted in red color are re-explored, and the two new boundary nodes are generated because of the increased depth bound. That's using memoise for iterative deepening. And next we will look at how to use memoise for regression checking. Here's a new version of EX. We changed minus delta to delta, and here's the GPF configuration file for that. We specify the locations of the two class versions, and we use ICSE listener for regression checking. So we write. So after running, we can check the try, and we can see that only one path is explored. This is because the change is made at this particular branch, and only this path could be potentially impacted by this change. Since the change doesn't introduce any new paths, the try remains the same as before. We know that memoise made 0 constraint solver calls and explored 5 states. We can run traditional symbol execution for comparison. So we run, and we find that traditional symbol execution explored 13 states and made 12 constraint solver calls. That's all for our demo. Welcome to download and use memoise. Thank you.